So I'm Chris Robison, lead data scientist at Overstockcom. I head up our marketing and fraud internal efforts.
I'm Michael Finger. I'm the director of software development at Overstock.com.
And we're here to tell you today about our journey of basically productionalizing machine learning models as we move from executing on a daily basis to minutes to seconds. But really what's underlining this story is how Mike and I learned to get along. So Overstock.com has been pushing the boundaries of retail since 1999. We're founded and headquartered in Midvale, Utah. How many of you have been to Utah before? Right, it's a fantastic place. For those of you that live in the Bay, our biggest recruiting pitch is I'm 30 and just bought my own home, so consider that. We have over 5 million products. We're selling to 160 countries worldwide. But the important thing for us as scientists, engineers, and all-around data geeks are the almost 20 years worth of weblog data. This is billions and billions of individual visits and page views that we can mine and try and leverage for our models. But we have to be able to operationalize that somehow. We have to be able to flow the data to and from where we need.
So when Chris and I started this journey about a year and a half ago, in the beginning we had a few data scientists. We had about 3 data scientists and a small engineering team, a couple of developers, QA, and a product owner. And then we had lots of chickens. Plenty of business owners and lots of channel managers and way more ideas than people to execute on it. So initially, some of the problems we were up against, data scientists weren't working with business to solve business problems, right? They're kind of off doing their own thing. Sometimes they didn't align directly with adding business value. Engineers were not working with data scientists. And engineering was in a relational data mindset. So a lot of our web services, microservices, were just kind of thin wrappers around an Oracle database doing CRUD operations. And that doesn't scale very well. You have to have lots and lots of instances of your web services. And engineering wasn't working that well with data scientists. We were still kind of siloed and didn't have a lot of exchange of ideas. And we weren't regularly delivering business value on a good cadence. Things were coming out maybe monthly or every couple of months. And at the end of the day, we were solving yesterday's business problems today. So initially when we started this, our first stab at it was doing things in nightly batch jobs. Not great, but it's a good starting point. So one of the first problems that data science and engineering came together to solve was real-time bidding. And RT bidding is a means by which advertising inventory is bought and sold on a pre-impression basis, similar to trading stocks in the stock market. And it's a low latency operation. You need to respond with a bid in less than 10 milliseconds. And to solve this initially, we started to pre-compute the scores nightly. And then we pushed the scores to Redis cache and AWS. And we partnered with a company with beeswax to get us a seat onto the bidding platform. And the whole goal of this was to replace our existing third-party partners. They were charging us a hefty markup for doing this on our behalf, and we knew we could do it cheaper and save the company money.
So the first problem that we had to solve as a group of data scientists was trying to identify a propensity to purchase. How likely is someone to convert based on what we can see from their profiles or weblog data? So the idea here is we're trying to separate general shopping patterns from actual conversion patterns. So we noticed a few things right off the bat. Excuse me. So for example, people tend to window shop during the day. We all do it both at our desks and on our breaks at work. But when they convert, a lot of our customers tend to convert on a tablet or PC versus window shopping on their cell phone. We also noticed some interesting indicators, like people tend to use their shopping cart as a wish list instead of using our actual wish list functionality. So people add to their cart and add to their cart and add to their cart, and then in my case, when my fiance gets involved and gives me a budget, we start to whittle cart items down. The sports memorabilia goes, the Victorian lamp stays, and we get towards kind of a final basket price. So our basic steps, we collect data at the visit and user level, and then we're going to turn those raw user interactions into features. We train classifiers on months of data and then execute on live sessions and visits as they're coming in. And we're, of course, trying to predict on those new information. So very quickly, we ran into some challenges. We have many, many new customers. In fact, the vast majority of people we see in the weblog data are new to us. We sell a lot of home goods, and so people are going to buy couches in a really active cycle unless they buy a new home maybe once every 3 years. So that gives them time to get a new cell phone, to replace their laptop, and at very least, clear their cookies. So it's hard for us to link things up and identify. We also have a very low conversion rate, and this is a problem for all of e-commerce. I can't quote exact numbers, but we sit right around the industry standard of 1.5% to 3% conversion, which means we have a huge class imbalance problem. And we need to sift through months and months, and once we got to kind of a final state, even a year's worth of data to identify enough actual conversion signal to differentiate in our algorithms. We had to look at oversampling techniques, and kind of some greedy oversampling worked quite well, and then we moved more towards a SMOTE framework. We're also, of course, interested in accuracy on that positive label. There's not a lot of consequence in this setting for us saying someone's likely to convert if they're only lukewarm on the product. It's not like the fraud setting where if we call an order fraud and delay it or cancel it, we're likely to lose a customer, and maybe for life. So we can kind of trade off some of these accuracy metrics as we go through.
So some of the challenges we were up against during this phase was we had a lot of constraints for the current infrastructure and processes. We were running, a lot of our data was in internal servers that don't scale as well as, say, the cloud. And like I mentioned, we're used to pulling data instead of streaming it. So going to the Oracle database was kind of the source of truth and pulling that information out. And then data scientists are a scarce resource. They're working on many non-relative tasks, rolling the data up and getting it there to their models rather than actually doing data science. And not a lot of experience in the care and feeding of enterprise software. A lot of our data scientists are like, well, it's working on my desktop, so that's good enough. We can roll it to the production, right? And a bit set in the academia mindset. Again, getting people used to delivering value in a regular cadence. And at the end of this phase, this is what it basically looked like. In the center, we had Oracle. We were flowing data to mParticle, which is our data hub that lets us federate our data and cleans it up a bit. And then we pushed it to Snowflake. And then we were able to use Databricks to query against Snowflake and do the learnings against that. And then, like I mentioned, that was pushed to AWS, where it was cached. And then it was able to do bids with beeswax. So a recap of kind of what we did here, or what we were able to accomplish in 6 months. We were solving today's problems by the end of the day. An okay place to be. Engineering was thinking about streaming data, which was kind of a big transformation for them. And then we had the pieces in place to start iterating on this and start scoring the user's scores in minutes instead of nightly batch jobs.
So at this point in our journey, and we're about 6 months down the road at this point, we started off with just a couple of devs and Mike and then myself and 3 other data scientists, 2 of whom are in the back, so thank you guys. And so we were running pretty lean and mean, but we got the skeleton stood up and working. So now we're able to iterate a little bit quicker, but we knew we needed to move faster. So in the context of this propensity to purchase score, we're potentially interacting with someone or pushing that score into our bidding engines nearly 24 hours after they've actually come to the site. And that's a lifetime in e-commerce. So we're thinking at this point, if we can get it down to 60 minutes, that gives us the opportunity that when someone's browsing online during their coffee break, we might catch them at lunch, or we catch them when they're back home and ready to actually convert. But everything's more top of mind. And so we had to score users faster. And that was a directive from the business that came up really quickly. We also picked up a new project, which was fraud prevention. And this brought an entirely new set of challenges to us. For one, the data was fundamentally different. Now we're trying to flow around PII data instead of just anonymized and hashed user IDs with almost meaningless features. And we also had to assign the fraud score within 5 minutes. And we had to beg, borrow, and steal to get those minutes out of what we call the buyer's remorse cycle. So we have to ingest every single order that comes through a $2 billion a year e-commerce website and determine whether they're fraudulent or not, assign a score to that, and then push that back to our internal system so our fraud agents can do something with it. And we, of course, ran into challenges. So when moving from daily batches to the more regular micro batches, we had hourly jobs, which of course meant much more responsive scoring. That was a big win for us. But now we have a much larger server footprint. We're doing everything 24 times a day rather than just once a day. Luckily, we could still train offline and daily, weekly, monthly, whatever made sense for the project at hand, but we had to have our pipelines better tuned. And then we really pushed the envelope in the fraud setting. We tried to tighten everything up into 5-minute batches. And this actually added a new data source for us because we're flowing out of our Oracle databases, our Terra databases, out of HDFS, all into Snowflake where we have to do complex joins. But like I said, this has to happen every 5 minutes, and we still have to have a minute or so in order to start up a Spark context and execute our job. So our ETL had to be tightly honed, and we actually ran into some interesting issues with consistency in S3 as we were reading and writing too quickly from different buckets, and the people at Databricks really helped us to address that. So we're hitting the edge of what's even possible in the batch setting once we get down towards minute execution. Then things really start to get difficult, and we had to look into streaming, which we'll talk about in the next section of our talks. One of the things our product people and kind of business owners didn't anticipate being as big an issue is having enough feedback loop. Right? So things are happening pretty rapid at this point. We're executing, when we're down to minute range, hundreds and hundreds of times a day. But how do we know how we're doing? How do we know if we can justify the server footprint? Or is it enough to just execute users every hour? And so we needed automated analytics pipelines to be able to tie those back to internal numbers and say, yes, we are doing the right thing. And you have to make some greedy decisions. So for things like, say, an average order size prediction, we knew that wasn't really going to change inter-day. And so it was enough to leave that in a daily batch. So we start to prioritize our jobs better at this point. And of course, as adoption increases, visibility increases. We had a pretty awesome sandbox at this point, and other kids on the playground wanted to come and play. And so we needed to standardize data representations. And this is really more a symptom of the project moving outside of our direct teams. So we had to come up with schemas, column names that made sense in the lingua franca of Overstock, so other people could easily come into this new environment and leverage our technology. We had to make sure the architecture is hardened and robust. We're moving out of POC phase and starting to be more in line not only with other microservices, but with the production shopping site. And so we needed fail-safe mechanisms for critical processes. If things fall down, we need to either be able to supply default scores, but no matter what, and no matter what happens, and no matter how great our engineering pipelines or machine learning models are, we can never, ever slow down the production shopping site. If we slow down the site, our tech is the first to go, and rightfully so.
So at the end of this phase, we basically had something that looked like this. On the left, we had a lot of different things that were consuming the user scores and attributes. And we're also starting to stream data in and out of Databricks directly, which was kind of a fundamental shift for us and allowed us to move a lot faster. So to kind of recap, we still needed to move faster. We weren't doing the near real time like we wanted to. But we were scoring fraud scores for orders in a minute or less at this point, which was good enough. And then we were scoring users in a minute or so. But we still had to do it in seconds. So at this point, we were trying to move to the near real time.
And so as we move towards near real-time personalization for the shopping site, we wanted to put custom recs in front of the user. So these are 3 examples of some experiences that you might see. These are, of course, nicely mocked up examples from our UX people. But we wanted to be able to customize content as users are coming in. And of course, we still can't slow down the site. So we're trying to figure out some network hopping issues. This is where we started to actually run up against the physical laws of physics. Electrons traveling around can only go so fast from Utah to wherever AWS's servers are that we're hitting. And we, of course, ran into several challenges. I don't think it's fair that I always have to read the challenge slides.
Well, you come up with the challenges and I solve them. So.
Yes, that's fair. So near real time can limit the size of models and complexity of calculations. So we aren't trading stocks. We don't make a commission on every single transaction. We're selling home goods with a low conversion rate. So we have to make sure that that cost-benefit analysis makes sense at every point, especially as we're getting greedier and greedier in terms of the tech side. And business partners can see Mike and I come in wide-eyed every morning as we want larger servers and more GPUs and more scientists and more engineers. We have to make all of that make sense.
And they open the AWS bill every month.
Yeah, then we get our talking to. So we also may not know much about a user we're trying to personalize for. People, like I said, clear their browsers. They're coming in very shallow to the site and may bounce after just a couple of page views. So what can we show those users? How can we cluster them to existing users? How can we do geofencing and leverage demographic information? And how can we come up with sort of a model that ended up looking almost like a tree where you navigate down depending on how much information we know about you and how deep you are into the site until we can actually start to pop very nuanced ML and AI algorithms. And the biggest challenge, and we kind of brought this up in the last section, but real-time data flow requires real-time analytics and strategy. When we're executing in real time and processes are reasonably automated, and this actually came up in most of the keynotes this morning, you have to have introspection. You have to understand what's going on so that you don't start to deliver systematically poor experiences, or you're not slowing down segments of the site. So introspection becomes key. We had to have automated processes to prevent our algorithms from running wild. And we also have to empower the business owners to operate strategically. I can't just turn my Kinesis stream on and say, okay, Joe, go ahead. What's your strategy? That's never going to work. So we had to figure out ways to distill this massive amount of information we're ingesting down to, at the very highest level, 4 or 5 bullet points that an executive can take into his morning meeting and talk about why what we implemented last night is working today. And of course, every piece of the process has to function as a cohesive flow. So this is where you start kind of asking yourself hard questions. As data scientists and engineers, we tend to be perfectionists. We want everything absolutely perfect all of the time, and that's how we're trained. But it may not be necessary. So take kind of the 2 examples we've been talking about. In the fraud case, it was absolutely worth it for us to wait a few minutes, to let all of the information collect, let all of the ETL complete and hydrate so that we can make an accurate decision. Because the cost of calling something fraud, if it isn't, is potentially a customer. So now we're talking about lifetime value loss. Whereas for recommendations on the shopping site, the most important thing is for the page to load fast. So even if we don't have perfect information about a customer, once we can start kicking these processes off and start to personalize content, that's key.
So this is where we are right now with Overstock. A lot of stuff going on here, a lot of data flowing around. But I think one of the big things to call out here is now we're starting to do Spark streaming. So I think we have the pieces in place we need to start doing real-time low latency operations for personalization. And to kind of recap what's done and not done, we're still not quite in near real-time low latency REX for the shopping site, but we're getting there. And fraud scores and email recommendations are fast enough, so it's a good. And kind of our roadmap, where we want to go next with this, we're working on pageless personalization. So kind of that like scrolling experience like you get on Pinterest and some other sites where you don't have to navigate the product pages and search result pages and things like that. We're also starting to explore deep learning for fraud. Fraudsters are really smart. They're always changing their strategies and trying to make themselves look like non-fraudsters. So trying to always update your model to keep ahead of them is kind of a losing battle. And balancing real-time needs with efficiency gains, like when is fast enough? Why keep working on something when it's working as good as it's going to get? And we all need to be daring and collaborative to accelerate innovation. So a few takeaways or lessons learned. The cloud presents a whole new set of problems. We've got really good job engineers at Overstock, and they're really good about writing enterprise code, but they don't know a lot about networking or security or things like that. So there's been some ramp up there. And tech is hard, politics are harder. Trying to execute change or revolutionary change in an old organization, sometimes a lot of your battles are just stepping on people's toes and talking to a lot of people. You can't operate in silos, both technical silos and business silos. You really need to always, come together and talk about your end goals. And you have to always be aligned with business. If you're off doing something that has no business value, your project's probably not going to get renewed or go anywhere. And the process must be iterative. You know, a lot of the things we learned when we first started this, doing the batch nightly jobs, we were able to change those up or iterate on them and get us to where we are with the near real-time personalization. And any questions or comments? And of course, we're hiring. So.
Always.
So I saw you were concentrating mostly on fraud. I mean, are there other problems that you're also working with, like being able to get more products to particular individuals? You mentioned in the earlier session, in the keynote session, that you watch people throughout their whole, or it seems kind of creepy, but you saw them buy their furniture, and then they saw them buy them when they're at the dorm room furniture. I mean, are you actually trying to also use ML to sell more to those individuals that you have a history with or whatever?
Sure. So specifically, we're attached to fraud and marketing. So those are our localized domains. But I can say with confidence, we're looking at every single nook and cranny of the company to see where ML and AI can help to both automate processes and pull out new information from this very large existing infrastructure. So we have other data science groups that are attached to logistics or merchandising and all those areas that you kind of touched on.
And like I think it was mentioned in the keynote, kind of sprinkling AI around the organization. We've got some of that going on. We're seeing where it can help. And then also things like I mentioned the pageless experience and things like that, like trying to think beyond just having a product page and a search page and a checkout page, like trying to get it in the one page. That might be a little more evolutionary within the scope of Overstock, what we're also doing with machine learning. So.
Yes.
Hi, sorry, just in terms of while the session is anonymous, when a new user approaches the site and you don't know, they've not been authenticated and stuff like that, have you guys developed any type of analysis to kind of market to that anonymous user in some way, or to kind of figure out who he is and implement strategy in order to get him to register or something to that extent?
Yeah, absolutely. I mean, one of our big outstanding issues is just bounce rate. And so if we can decrease that bounce rate and kind of increase recidivism by even margins of a %, that ends up being millions of dollars at the end of the year. And so it comes down to essentially asking yourself, what does this user look like in terms of our users that are authenticated? And can we learn something from their experience and their interaction, and then try to push to them the content that they need? But it's a very kind of difficult problem in a sticky game. We don't have a kind of I guess, what would you say, like cords, or we're not selling toilet paper. So people aren't buying from us on these really regular cadences. So we have large gaps in the buying cycle as well, and that complicates things even more.
Once you buy a sofa, you don't buy another one every month.
Yeah.
Hopefully.
Hello. Great content, thank you. Just a quick question. Some of the struggles around doing real-time personalization, serving real-time personalization content, how did you guys try to approach featureization in real time? Maybe can you give us some like just high-level overview?
And did you say featureization in real time?
Yeah.
Feature rollout. You look at a lot of like the real-time bidding and things like that. A lot of the architecture they've come up with that. But I guess to kind of condense it into a thing is you have your events flowing in. You're trying to roll them up and put them into like a Scylla database or something like that that has a pretty good response time. And then when you need to make a personalization for someone, you can pull out that data set out of the cache and then use the data you have in there to make the recs. So again, you're kind of operating on what you know. Because if someone's going around the site and surfing, and trying to make those recommendations in near real time, like the data set isn't complete, if that makes sense. Like it's always changing. So you just have to go on what you know. And hopefully you can do some work in getting the really pertinent things there as fast as possible. Say like, the pages they've been gone to and they're going to. So if they've been looking at 10 red couch product pages, then you probably want to make some recommendations around red couches. So really focus on those two. And then other things might flow in afterwards.
Yeah, and I'd add to that, we're definitely utilizing the latest version of the Spark structured streaming API, where we can actually take all of these streaming sources and join them to a static source, which was a big game changer for us. So Sean and Steven in the back of the room are spending day and night writing UDFs, kind of rolling up new features as we build out this larger code base to represent what a session is for a user, what these larger interactions are, so that we have consumable real-time features for people that aren't engineers or data scientists. It's really empowered a lot of our analysts as well. Yeah.
How do you define a specific session is a fraud session? It's very high level, and what are the major attributes you are looking, especially to design the score of the fraud?
Yeah, so initially, we actually kind of sat down with some of our business owners, and one of them was a VP who's been in retail for a very, very long time, and he was able to kind of point us in the right direction right off the bat. You know, I didn't come to Overstock as a marketer. I had worked in a string of tech startups, you know, certainly not around marketing. And so a lot of it was just kind of collaborating, like in kind of confirming our own hypotheses. We stumbled on some interesting things, but a lot of it was pretty natural. Like we knew that people were window shopping during the day, and we're more likely to convert later on in the evening, things like that, especially on large goods. I mean, we're talking couches are fairly expensive, so it's a weighty decision. You're not just buying a book that someone recommends to you in the office. And it was a lot of exploratory analysis, so a lot of kind of looking at when we started with an initial feature set, which I think was somewhere around 50 features, what were the distributions? When were those distributions changing? And so we used a lot of classical statistics to help us along the way and recognize those fundamental changes.
And another kind of challenge we face, and a lot of retailers are facing, is, right, you got your phone, you surf on the phone, or maybe you're at the furniture store and you're like, oh, this is a cool sofa, and you do some lookup, and then you go home and you want to look in your big monitor at home of all the pictures of that sofa. So you've got customers that are going across 2 or more devices and trying to roll that up and figure out those sessions. So.
All right, guys, thanks a lot, Chris. And the next session will start in 10 minutes, so thanks a lot, guys.